All right, these are some test questions off the 5 and 6 test. I would just go over. I'm just going to go over a little bit. I'm not going to go over in detail, but here's one right here. First thing you do, and we went over several of these in class. First thing you're going to do is set them equal to each other. Now you can do this in the calculator. You can find their intersection points in the calculator, however you want to do it. X squared minus 4x plus 3 is equal to x minus 1 minus x be plus 3 plus 1, sorry, bring that over. So x squared minus 5x plus 4 is equal to 0. Reverse FOIL, x, 1 and 4, negative and negative. And we got an intersection point at 1 and an intersection point at 4. So your 2 points of intersection are 1 and 4. So you set up your antiderivative. I'm just going to do setups. So that's going to be area or volume. Let's see, this is say find the volume, find the area. So that's going to be length times width. Okay. So volume or area is equal to from 1 to 4. And that's going to be your your dominant is going to be the x minus 1. So that's going to be x minus 1 minus x squared minus 4x plus 3 dx. And that's going to be your derivative. You can distribute antiderivative 1 to 4, x minus 1 minus x squared minus be plus 4x minus 3 dx. And the x's are going to, so that's going to be area from 1 to 4 of negative x squared plus 5x minus 4 dx. And there's your setup. Okay. And I'm not trying to trick you on a lot of these questions. A lot of these questions are going to be straight and to the point. So, and your answer there is 9/2. Next. Same type question, except you don't have to worry about subtracting because y is equal to 0 is the x-axis. So square root of x minus 0 is square root of x. So you just have to go from 0 to 9 of the square root of x, which is x to the 1/2. And okay, x equal to 4. Okay, they switched it when I hit that. So, and x equal to 4, there's your setup. They're asking for volume here. So that's where you throw your pi in there, 2 pi. Sorry. And I think it said by the shell method, so that's why it's 2 pi. And 8 pi. And I think we did one like this in class. I'm pretty sure we did. Next. Okay, use the change of variables to evaluate. We did one like this the other day. You're going to let x equal to x squared plus 1. And I'll just go through the substitution for you. U equal to x squared plus 1. Therefore, du is equal to 2x dx. And we have 2x dx. So this is, and u If you plug in 0, you're going to get 1, and 1, you're going to get 2 of du over u squared. And du over u squared, that's the same thing as 1 to 2 of u to the negative 2 du. And that's going to be u to the negative 1 over negative 1, evaluated at 1 and 2, which is negative 1 over u. That negative goes right here. There's the 1. There's the 1. Evaluated at 1 and 2. And that looks like negative 1 half minus 1 over 1. And 2 over 2. So 1 minus 2 over 2. Negative 3 over 2, it looks like. Might have my sign messed up there. X squared plus 1. 1 to 2. It's 1/2. I got my sign messed up. It's 1/2. Should be a plus. Yes, it's a negative. Sorry. Negative and negative right here. That negative and that negative. This is minus, and then this negative. So it should be 1/2. Okay. And we did one like this one in class. I'm pretty sure we did. Okay, again, we've got a, looks like u, and I'll just do the preliminary part of it. It's an indefinite, so you don't have to plug in anything. So I'm going to rewrite it as x to the 5th minus 2 to the 5th power x to the 4th dx. So u is going to be equal to x to the 5th minus 2. So du is going to equal 5x to the 4th dx. And we've got a 5 here. So I take my handy dandy colors and I put a 5 here. And I put a 1/5 here. So now I've got, excuse me, now I've got 1/5 antiderivative of u to the 5th du, which is u to the 6th over 6 times 1/5 du. And that's going to be u to the 6th over 30 du. And that's going to be, sorry, you don't need the du after you take the derivative, antiderivative. And u is x to the 5th minus 2 to the 6th power over 30 plus c, or something like that. 1 over 30 x to the 5th minus 2 to the 6th plus c. Any of those. Again, straight to the point, not trying to confuse you. Next. Okay, I'm not going to go through this one because this is one of the easier ones. I'll go ahead and give you one that's got the answer. There's one right there. So 4x to the 3rd. Take the antiderivative and plug in -3 and 4. And that's pretty simple. Same thing here. Now be careful. The derivative of e to the 3x, the antiderivative of e to the 3x is e to the 3x over 3. Remember, parentheses around the 3x. So you got to remember that. So pull that 12 out, the antiderivative of e to the 3x. I'll go ahead and start it off for you. I'm not going to do the math, but antiderivative from 0 to 3, 12 e to the 3x dx. And I'm putting the parentheses around there to make sure you remember But you got to take the antiderivative according to that 3x. So that's going to be 12 times e to the 3x over 3, evaluated at 0 and 3, and that's 4e to the 3x, evaluated at 0 and 3, and that's all I'm going to give you. You should be able to finish it. And I'll give you one with the answer. There's one with the answer. Okay, they don't even, okay, they do. Okay, no, they just wanted the setup. They don't want the answer. Another one, same thing. I would do 0 to 2 and then multiply it by 2. That's what I would do. And you can break that up into 2. Take the 9 out, break it up. The antiderivative x to the 8 minus the antiderivative of 3. I'll start that one off for you. Let's do one with the answer, so that way it'll. So antiderivative from -1 to 1 of 8x to the 8th minus 7 dx. Well, I would do from 0 to 1. I would do 2 times 0 to 1 of 8x to the 8th minus 7 dx. And then, of course, you could take the antiderivative here. That would be 2 times, that's 8x to the 9th over 9 minus 7x period, 0 to 1. And then 0 cancels everything there. And you're going to have 8/9 minus 8/9 minus 7 over 1. And that's going to give you your answer. And don't forget to multiply it by 2. And 7 will go into 9. I think it's, you see, 9 times 7 is 63. And that's going to be 2 times 63. So, or whatever it comes out to be. Okay, next. Another one, that's the same one that was a while ago. I'm not going to show you. No, just take that one off. That's the same one we did a while ago. Here's another one. And it looks like it's just going to be, now that's pi over 2, so this is pi over 4. So it crosses at pi over 4. So you're going to do the antiderivative from 0 to pi over 4. And then from pi over 4 to pi over 2, you're going to do the cosine. Okay, so remember, I'll set it up for you. The blue line, I'm going to draw this. Let me do a blue line and a red line. Okay, I'm not really care if it's to scale or not. I just want to show you something. We know this is pi over 2. This is pi over 2. So this is going to be pi over 4. So the blue line is there to pi over 4. And the red line is from pi over 4 to pi over 2. So you got to make sure you set up your, you're going to find this area. Is it area? Find the area. So you got to find this area. And that's going to be from 0 to pi over 4. And that's going to be That's going to be 5 sine of theta, so you put the 5 out here. Sine of theta. And then plus from pi over 2, pi over 4, pi over 2. And that's going to be this area, which is going to be 5 cosine of theta. And dx, and dx. And that's nothing but looking at your cheat sheet for sine and cosine, and then plugging and chugging in your calculator. Okay? And I'll give you another one that has the answer to it. Let me go ahead and change the problem. There you go. You can do that one. I'll leave that on there for a few seconds. And you can pause the video and do this one. See if you can see. They don't even want you to do the math. They just want you to do it by hand. So it's not that bad. Next. Okay, we did this one in class. So I'm not going to go through this one because if I remember that we did it in class, I'm not going to do it again for the test. Okay? And it says by the shell method. So you got to put 2 pi in there. Don't forget the 2 pi. And that's going to be from 0 to 1 of x minus x squared. That's it. So you really don't have to do anything extra. I'll give you one question with the answer. And there it is. There's your 2 pi. And remember, your x is your diameter, so it's going to be x times 8x minus x squared. I'll leave that pause there for a minute so you can actually work it. And there is the answer, 2048 pi over 3. Now, I'm not going to go over too many more of these because shell was the last thing that we did, and that is pretty much going to be the extent of a shell, but we'll go ahead and let you look at the next 10 problems. Find the area between the curve and the x-axis over the indicated interval. I'm not going to do that's 6x to the negative 1, and you should be able to do that one. That's one of your elementary problems. 6x to the negative 1. I'll give you another one. There you go. 7 over x. I'm sorry, 7 over x to the negative 1. And that's the natural log. So you could write it as 7 times 1 over x. And we know that 1 over x is natural log. So it comes out to be, you can't take the natural log of 1, so it just comes out to be the natural log of 6. And I think we may have done one like that in class. Use the substitution form. U is equal to 3x plus 4. Du is equal to 3 dx. So you got to put a 3 here and a 1/3 out front. Give you one of the answers. There's one right there. And then take the antiderivative. So 5x plus 4, 5 dx, put a 5 here, a 1/5 on the outside. And then you take the derivative of u to the 1/2, which would be u to the 3/2 over 3/2, which would be 2/3, and that's where you get the 15. 2/3 times 1/5 is 2 over 15. And we've done several of these in class. Not a very difficult problem here because you're going from 0 to 2 and you're finding the volume revolving the shaded region about the x-axis. Okay, so that shouldn't be very difficult. Going from 0 to 2. I don't see anything about a shell, so that means you can actually use a disk. It's going to be a disk anyway. 0 to 2. Volume be pi. And this function is negative 5x plus 10. So x times 5x plus 10. And I'll give you one with the answer. There's one with the answer. This is going to be from 0 to 2 of x, negative 2x plus 4. And crunch all that out, and you should get 32/3 pi. Substitution, I would rewrite it as x squared plus 3 to the 5th, 2x dx. 2x dx is there. So this is basically u to the 5th du. So that's going to be u to the 6th over 6. And that's going to be x squared plus 3 to the 6th over 6. Another u. Okay, that's going to be 4s, negative 4s ds, 4x cubed ds, and you got a 16 there. So you got to multiply that by 1/4 and multiply the outside by 4. And that's going to be du over u to the 1/2 power, which would be u to the negative 1/2 du, and that's going to come out to be u to the 3/2. I'm sorry, u to the 1/2 over 1/2, which is 2 times u to the 1/2. So that's where the 2 comes from, and the 2 is multiplied by 1/4 or 4, so that's going to be an 8. I believe it's either going to be negative 8 or negative 8 down here. So it's going to be alpha or delta. Next, another easy one. This is find the volume of solid revolving the shaded region about another disk. So R, that's going to be length, but R is going to be x. So x times 2 minus 3x from 0 to 2/3. Okay. The composite function consists of an inner function g and an outer function f. When doing a change of variables, which function is often a likely choice for the new variable u? That could be g of x. Right there. So that's not a big deal. I didn't know that one was in there, but g of x is usually your u function. Substitution, 4x dx, that'd be 4 dx. You put a 4 in here and a 1/4 out front. So your answer is going to be 1/4 4x plus 2 to the 3/2 over 3/2. So that'd be 8. It'd be something like that. Again, another u substitution would be 4x to the 4th. You got a 4, you put a 1/4 out front. And therefore, you have u to the 5th du. So that's u to the 6th over 6. U to the 6 over 6, which means you're going to have a 4 over 6, which is 2/3. Or 4 over 6. So I don't know. You'd have to see what happens. Or we could start it off. Because I got twisted in my brain. Antiderivative of x to the 5th minus 3 to the 5th power, x to the 4th dx. U is equal to x to the 5th minus 3. What am I doing? Oh. So du is equal to 5x to the 4th dx. So I said 4, that's why. So you want to put a 5 here and a 1/5 here. So that's going to be 1/5 u to the 5th du, which is u to the 6th over 6, multiplied by 1/5, which is 1/30. 5 or x to the 5th minus 3 to the 6th power plus c, something like that. Be 1/30th. Looks like that one. It's Charlie. Same thing, substitution, and that's it. So the main thing you need to see on this test is that I didn't pull any punches. I didn't try to confuse you. I did exactly what was in the class. Okay? And that's pretty much the test and the final exam. So if you can do all the unit tests and you did good on all the unit tests, then you should be good with the final exam. Y'all have a good semester break, and I hope to see y'all in the fall. I'm not teaching Calc 2, but if you need any help, holler at me. Talk to you later. Have a good break.